I'll send her my heart covered as a gift, and hope that you'll take it into her side.
Okay, my name's Graham Oakley. I'm a director for the Efficiency Group. We do lots of other things, but one of our main core businesses is laundry efficiency. What we try to do as a business, we try and make companies more efficient, more green, and obviously the more cold washing you can do, the more efficient you'll be from energy savings. So I just want to do a little context. It's about 20 minutes the talk I've got. So as we go through, if you've got any questions you want to ask me at that time, just ask me. And then we can go forward, okay? So I want to talk about the origins of ozone and how we first started cleaning, the environmental impact of traditional cleaning, what our system does to help you reduce your carbon footprint, the impact itself of using our system, the environmental benefits of using ozone in cleaning systems, that's not just for laundry, that could be for other industries as well. The sanitation, disinfection side benefits of using ozone, and the financial benefits, obviously, if you can reduce your carbon footprint, you're going to be saving money. So from a commercial point of view, ozone was first used in 1906. It was used in Nice in France, and it was used for purification of the water. So all the water in France was actually purified. What they found when they first started working with electrical items, there was a funny smell that came off electrical. So all the buzzing and that is where Tesla and people like that, that's where ozone came from. But it wasn't really until early 1900s that they actually realised that they could use it to a benefit. By 1940, aqueous ozone was being used by the Navy. So the Navy realised if they used their guys with swimming in ozonated water, the water was sterile, it was clean, it didn't affect the eyes of the guys, so they had a better way. By 1976, the US gave approval for it to be used in the food industry and other industries for cleaning, so breweries, wineries, places like that. So instead of using your peracetic acids and all things like that, that was brought in to replace that. From 1984, the Olympics started using ozonated water. Similar to the Navy in a lot of respects, the contenders never had sore eyes. More importantly, by the 80s, they were filming underwater with the cameras. So when you've got chlorine in the water, you can't actually see the bottom. When you look for yourself in chlorinated pools, you can't see the bottom. Where ozone water doesn't change the structure of the water in the sense of visibility, so then they can actually film underwater, as well as the health benefits. The other thing is, when you put chlorine into water, there's actually a bit of resistance. So the ozone actually made it so the pools were quicker for swimming, and that's when a lot of records were broken. And by 1994, Space Kennedy were using it for their parachutes. So this is really how ozone started getting into the laundry industry. So they were sending the rockets up into space. When they were coming back, the parachute was dirty and they wanted to clean it. And what some special boffin decided was, well, I need to check the fabric tension and see if it's still got the structure and the strength. And what they found is, under a microscope, the chemicals they were using, it was actually weakening the fabrics. So they're having to make new parachutes every time because they're worried about them failing, especially with everything being on TV. The other issue they had was, because they were using harsh chemicals, because it's in the Everglades, the water they discharge actually goes into the Everglades. So they also wanted another way of trying to reduce, make it more ethically green for the wildlife, obviously with the eagles and all the rest that's there, and the alligators. So, as you all know, from a traditional point of view, a laundry uses lots of energy, yeah, and it's all dead energy. You're pumping steam or using electrolytes to heat the water, and once you've done that, there's no real big way of collecting that water. You can get some heat sources, but you're still going to have to need energy to heat that water to the final temperature you want. It's a very water intensive, so we use lots of chemicals. So when you use lots of chemicals, you've got to rinse those chemicals out. So again, you use bigger dips and else and else. And obviously, I've just mentioned the contaminant. So, as part of the global thing that's going on at the moment, I'll just thought I'd give you a couple of facts. On average, each water facility plant releases more than 4 million pieces of microplastics into the S waters every day. 6% of fibres, which is your lint, 30% is beads and 6% is film and foams. Okay. Now, this year there's been a study by Leeds University, and their claim is, and it's on the internet for you to see, using a 30-minute wash cycle at 25 degrees produces half of as many microfibers, the lint, as a normal full 85-minute wash at 45 degrees, and it uses 66% less energy. Now obviously that's from a domestic machine, because that's 85-minute time, but it gives you the impact and importance that if we're not doing lots of agitation and we're not using lots of temperatures, you haven't got the thermal breakdown and the fibres coming out the linen. So if I come into our system, then there is other ozone systems out there. There's a couple of guys in the room got ozone systems, so I'm not going to say which is better or not, apart from ours is better. So our system is slightly different to everybody else's. So if I talk about how traditional ozone was done many years ago, so if you think of a fish tank, and that fish tank is a washing machine. Now what they did, they put an air brick, for simple terms, in the middle of that washing machine. What they did then is pump the ozone gas through a little air brick, and then bubbles came through the water. Okay, now that's not a very efficient way of trying to get ozone into the water, but what it did have some sanitation benefits. So if you've got a piece of linen, and run that through at the tank, when those bubbles of ozone actually touch that linen, it was sanitising and having an effect. On the very early systems, 20 years ago, what they decided on, we're not getting the efficiency. So to increase that efficiency, they put more bubbles in. The more bubbles are in, the worse it was for the environment of the staff. So from an ozone point of view, there's one real negative from it. Ozone will damage your lungs if you don't control the ozone. If the ozone's controlled, it's actually better for us. So from a medical point of view, if you've got asthma and sort of allergies, you'll actually leave in a room and it will pump ozone into that room, and what that will kill the bacteria, mould and spores in the air and actually give you cleaner air. So in our offices, we've got a system similar to that, and basically we keep the air nice and clean. Like everything, if you took one aspirin a day, it's better for you. If you go to the other end of the scale and you took a bottle of aspirins, it's no good for you. And ozone's no different. The difference is if you filled this room full of high level of ozone, you'd walk in, you'd cough, you'd splutter and you'd leave it, like if you got a bag of chemicals and chuck that in the air. So to be exposed at high level once wouldn't actually do any harm. It's only persistent high levels of ozone that create any problems. So what was happening in the early days, they were filling the machines full of lots of ozone, open the door and you had a high level of gas. And that's why in the early days people started coming away from it, because the staff didn't like that. Now what we do differently, we've actually got the technology where we make the ozone part of the structure of the water. So instead of having bubbles coming out of the water, it's held within the water for 20 minutes. That gives us some more efficacies and stops that off an issue. So when you fill a tank full of water, you can put your head over the top and there's no gas coming towards you. And again, when you put that towel through, hold that towel to get saturated in ozone. Okay? So that's a bit of a difference between the traditional and what we do now, different to everybody else. Obviously, because it's a soluble, it gives us more efficiencies as well. So we're not looking that you've got a round ball of washing and the bubbles are going around the outside. You're getting into the middle of the wash and all the way through. Okay. So traditionally, what chemical companies used to do is that they have to raise your pH of your water to 11, 12 plus on the pH to create a thing called oxyradicals. Oxyradicals is a natural bleaching process. So when you get your pH high, so with your alkali boost or it's already built in the detergent, once you get above 12, you are getting a natural bleaching process. That is quite abrasive to your linen, but because you all want white linen, I'm sure of that, that's the way you get around it. What's different to our system is we don't need those high pHs. Ozone will actually work between 7 and 8 on a pH scale, so we don't need to use harsh levels of alkalis or detergents. So the fact we don't need to put all these chemicals in is a bonus to the environment. Because we wash in lower levels of water, we don't use as much chemical either. We try and keep the depth levels as low as we can to ensure that we don't use any excess chemicals. By doing that, if there's not so much chemical in your linen, you don't need as much water to rinse the chemicals out, which again gives you more efficiencies and is better for your linen. Typically we reduce chemicals by around 50% of a customer. It does depend on what you're washing. Obviously if you've got a business that's mainly table linen and things like that. It's not going to be good as someone who's just doing your flat work with your hotel towels and sheets. Not only do we alter the water, we actually look to wash everything we can as cold as possible. So with the days of washing everything at 60 or 80 degrees, right, our business model's gone. It's all dead energy and waste of and effort. What we try to do is wash as much as ambient water temperature, which typically is between 12 and 18 degrees. So if you've not got to heat the water, you've got the efficiency of not having to use the boiler, but you've got the efficiency of the washing machine. So your washing machine, how that typically works is, it'll ask for how much water you want, tick, and it'll move on. Do you need any heat? Tick, move on. So you haven't got any stages where the machine's actually waiting to heat the water. So the quicker you fill your washing machine, the quicker your processes are. Okay? So generally, we go to laundries and it's about a 55-minute wash between 60 and 80 degrees. And what we do, if that's your flat work, your towels, we reduce that to about 27 minutes. So you're getting a lot more efficiency. As I mentioned, we reduce the water by between 40 and 50%. Obviously, the more you reduce that, the less discharge. And what we're trying to do is, while reducing your chemicals, we actually try to reduce your effluent as well. Ozone is a good way of breaking down and taking the linens into a better position. Drying time. So in drying time, we can actually reduce time by 20%. Now how that works is, as you have linen and it goes through the processes, it actually coats up with the chemical. You don't always get all the chemicals out. So what you get is a chemical retention. That chemical retention actually holds onto the water. So when it holds onto that water goes into your dryers. So if you've got a typical load of 100 kilos, you'll be taking around 75 kilos of water on top of that into your dryer. By using our system in Ozone, you actually open up the fibres, and because we're using less chemical, it's all rinsed out. You're not taking that so much water over, so typically it's go from 175 kilos a towel to 135. So you're only taking 35 kilos of water over. So common sense says you're going to use less energy to dry that out. Okay. Further benefits are, obviously, if you're not overdosing the chemicals in and your linen's opening the fibres up, you're going to get one consistency of white. What you find typically when we go in places, the linen you've bought now and what it looks like in 2-3 years' time is a lot yellower. And again, that's just basically you've not got all the chemical out the linen. With Ozone, it's a natural sanitizer and deodorizer, so if you've got nursing homes or chefs wear or things like that, we'll actually strip out, sterilise it and neutralise the bacteria. Bacteria are like a 4-day cycle. You've got the eggs hatching, it's alive and it's dying. The last 2 is when it smells. Okay, wherever the smell might be, that's what it's doing. If you spray certain chemicals and cleaners on it, it will kill the first 2, maybe some of the eggs that are already hatching. What Ozone does differently, it actually hits the bacteria and it explodes. It's a mini explosion. So what that either does is either ruptures the egg or completely destroys the egg. If an egg is ruptured or destroyed, that bacteria can't grow. And that's why it's so effective of keeping the bacteria and smells away. Obviously, with the less agitation, the less thermal items going on, the linen will last 3 to 4 times longer. Okay? We've got evidence on that. Telford Laundry now using linen that's 6 years old, and it still looks the same colour and still in the process, and it's doing the job. Obviously, we're getting all the chemicals out and everything else. Your towels are going to be fluffier, softer. There are companies out there do actually sell chemicals that help with that as well. Obviously, I've talked about others, and the bottom one is an interesting one. Helps eliminate skin irritation. Most people think bed sores are sores. What bed sores are, it's chemical left in the linen. So what you've got, when the chemical's left in the linen, it forms a little crystal. That little crystal scratches at your skin, and when you're in bed for a long time and you sweat, that actually opens up your skin, and it's more of a chemical burn than a sore, and that's how they're formed. So we can actually help to eliminate that part of it as well. So what we aim to do for a customer is obviously reduce the water, reduce the power, and reduce the chemicals. Now we've got to use chemicals. There's no way you can't use chemicals, which the guys over there will be happy to hear. Basically, you've still got to remove the fats. You've still got to have a way of taking the soiling down the drain. So don't think if you go for any Ozone system that you can eliminate chemicals. There was rumours years ago that was possible. It's not. You still need detergents. You still need things to take down the drain. Obviously, if we can lower your rewash levels, again, that's a 100% saving. If you can reduce your wash level, it's 100% labour saving, water, gas, etc., etc. We've had customers where we've got into, their water levels have been around 10%, and we now got them running at 5%. There's a video of Guarantee Linen on our YouTube channel, and they actually say they've reduced that and the savings they're getting, and they only do 4- and 5-star hotels. That gives you an idea. It's not just little laundries, it's big 4- and 5-star laundries that we can help. And obviously there's the microfiber pollution. Because we're washing in cold, and it's only a 27-minute wash, we're not releasing so many fibres, so much lint. So your drains are going to be cleaner, and the ozone will actually clean and take your drains cleaner as well. So any excess ozone that goes into the drain will clean your drains. These are some of the things that ozone kills. Okay, these are actually stats. So from a bacteria point of view, Listeria, coli. From a virus point of view, it kills the flu virus. I can't say corona for obvious reasons. But the virus from the flu virus is very close to corona, although no one's done any tests. Everything that comes from space is actually washed with ozone water. It's known to kill everything known to man. So we see that we should be able to kill corona, but we've got no evidence on that. So what you've got there is all the different things, yeast. So there's lots of different things we can do for you. HIV, hepatitis A, some big things there that we can kill in your laundry for your customers. Okay, so typically it's 40% reduction on gas for our customers, a 50% reduction on electricity because the machines aren't working so long, or you're going to get double the production in the same hour. So a 100 kilo machine becomes a 200 kilo machine because you can get in that machine turned around twice in an hour. Obviously we reduce the chemicals, because water consumption, and typically we'll have around 30 to 50% increase in production, and then we can reduce labour costs. Obviously, if you're getting 2 washes out in that same hour, you don't need to run for so many hours a day. Theoretically, if you're running 12 hours a day, you might reduce that to 6 or 7. So that can be a massive saving, not only on your staff, but your boiler usage and times like that. And here's a few of the awards we've won over the last few years. I was actually at an award ceremony on Friday. We won Environmental Business of the Year for the West Midlands, and we're now finalists for London in May. And we won it the year before that. We've won the 2018 Lard Awards, which Mark puts on for everybody, it looks nice. And we was in the finals this last year. And we also are doing some stuff with Kiel University. So we've just devised a software package where we can come into your laundry and we can actually tell you the exact carbon footprint you're creating. So if we've got any idea what your customer is doing, we can actually say you've actually reduced the carbon footprint for that customer to this level. And we are talking about doing little plaques and things for your customers so they can put it up in there for you. So you're working with both of us and we're creating you a cleaner, better laundry and a better way forward. We've also developed a new chemical. So we're looking at the NHS market and nursing home market. So we know when it comes out of the washing machine we can get it sterile. But as soon as someone touches that linen, you're back to, well, is it validated or not? Now, obviously we all touch the linen in the NHS side of things. But what we've done, we've worked with the company and we now got an additive that goes in the final rinse. What that additive does now, keeps that linen sterile, it can be dried, touched, and it will last for 3 to 6 months on the shelf. So we see that being a big plus. People, hotels, some hotels are already asking about this product because they're concerned about neurovirus and other things. So if they can say to the customers it's sterilised and used in ozone as the first defence, the second defence is there's a product in there that keeps it sterile for another 3 to 6 months. It's another sell-on point for the customer, and obviously for you guys it's another sale there, you can get more money for your wash. And that's it. Anybody got any questions?
Can I ask the first question?
Of course you can.
I've been following Ozone ever since the days it didn't work.
Yes. Just like a nice question to start with.
One of the problems, well, it's got a lot of problems. One is it dies after, it's killed after 40 degrees centigrade.
Yes, the half-life is altered by 41 degrees, yeah.
But how do you maintain the level of ozone? Because it's dependent
so we got-
on an amount of ozone being present, isn't
Yeah,
it?
so our machines, well, we've got two types of machines that we use. So our main machine that most people buy, the machine is calibrated, so when we come to your laundry, we have to set it and calibrate it to your laundry. Okay, so we've got so many parts a million that we know is the right level for you. So everybody's got a different pump, they've got different water flow systems, pipe work, everything else. So we tune that machine to your system, and we make sure that when it's coming out into your machine that the ozone's the right level. Okay, that's the one part machine. The new machine that we've developed now is got a lot more PC background. Again, I'm looking for the NHS market. They want to validate it. So the new machines, what they do, they've got sensors in them. So that sensor will tell you every time that ozone passes through the machine, the level's correct. If it's not, it will alarm. It will tell me at head office if the machine's actually working, and someone's doing it on in the morning. So, and I can do a lot more bits and pieces, but if I keep that simple. So there's machines and technology there, so we know that stuff's
So
working.
maintains it all the way through
Yes.
the wash process?
Yes. And obviously, yes?
Fascinating presentation. In terms of, there's obviously an extra cost, I'm not laundry.
Yeah, no problem.
In terms of the extra cost, what's the return on investment?
It's normally 2 to 3 times the return on investment each month. So typically, if you had one of our larger machines, that'd be around $750 if you rented it, about $650 if you bought it for yourself on finance, and typically you'll be getting $2,500 return each month on your energy bills, chemical savings, and efficiencies. I mean, some people get a lot more than that, but we try and bring that down so people's expectations are realistic.
Graham, I'm a bit rusty in these things, but this ozone, you obviously don't get it in a bag. Presumably it's made on your premises.
Yes, so basically, yeah, sorry, I should have said that. So ozone cannot be stored. Okay, it only leaves for about 20 minutes. Okay, so what you have to do, you have to have a machine in situ. So what happens is your machine and the washing machine will call for water. That will act our machine off. As soon as we've got flow switches, so as soon as the machine clicks in, water flows through, it's adding ozone straight away. And that's how we control the ozone in. So there's no way, if you could bottle it, everybody would be selling it.
As a boy, I was always told that ozone was found in the underground, because when the underground trains spark, they
Yes.
produce ozone.
Yeah, so-
presumably ozone is made from sparking electricity.
Yes, so
How
ozone,
much electricity do you use to make your ozone?
so it runs off a 13 amp plug, and it's like running a 100 watt light bulb, one of our machines. They're very efficient. So the easiest way to describe ozone, you've got 2 oxygen atoms. If you squeeze them together and squeeze them a bit more, the O1 pops out, and then if you squeeze it again, O3. Okay, what we do then is put electrical charge over that, and that makes it more efficient and does what we want it to do. In the real world, the ozone layer is actually made from the sun rays. So the UV light of the sun creates the ozone layer. Now last year, the ozone layer was the smallest it's ever been. Now I know not people know that because the press don't talk about good environment news, do they? They only talk about the negative. But last year, the ozone layer was the smallest it's ever been. Okay? On Earth, it's a little bit different. It's still the same with the fact you need UV light. So every time you use a printer, photocopier, you're creating a small amount of ozone because it uses the UV light to dry the inks. And there's other things in the home that do the same thing, but it's only a very small amount. In nature, in the sense, you've got lightning. Lightning gives you high electricity and UV light, which is the same as the spark of a train. So when you have a thunderstorm and a lightning storm, and you come out and it smells fresh and clean, it's actually the ozone off that that actually clean the air up. So when it smells fresh and clean, it's probably ozone you're smelling. Okay? So with us, what we do in our machine, we actually collect the air. The air we breathe now is around 20-21% oxygen. And what we do, we actually strip the nitrogens out the air, which gives you a stronger, better oxygen. And we actually take it to a medical grade. So the better your oxygen, the better your ozone will be. What we do then is use that medical grade oxygen, and we actually put that over a lightning storm with UV light, and that's how we create our ozone, and that's how we can get it so strong where some other people can't get it that strong.
How is it soluble in the water in the wash process?
So what we've done, we devised a way of actually making it part of the structure of the water. So it goes into our machine and we disrupt the water to the point where it actually becomes part of the water. So once it's in the water and it can't come out, it will stop in that water for about 20 minutes. And the reason we try to get it for 20 minutes is because we know in 20 minutes it should be dead, or very little strength to it. So the problem with off-gassing, that was the old problem with the old system, we've engineered that way. So when you're in the water, and the best way to describe it, we've got a lot of layers in the water, and them layers stop the bubbles coming out. Anybody else?
I've got millions of them. Right. You mentioned earlier about its limitations and what it can wash and what it can't.
Yes.
You mentioned table linen had problems.
So from a ozone point of view, the colder the water, the better the ozone will be. Okay, it's got like if you get the efficacy right in the water, it has got like a peroxide effect to it. Okay, and that's why it does help lighten your linen. From a table linen point of view, you've got fats and greases that unless you've got the right chemicals that'll fetch those fats out, you're going to have to use a bit of temperature. Now we use all companies, so whatever company you're using now for chemicals, you use them. So obviously we've got Ecolab, Christane's with customers of ours, we've got Ideal and all the other names you've heard of, and we use their chemicals as anybody else's. And what we do, we just reduce what we think we need of their chemical. Okay? So if you're thinking of table linen, we probably need more emulsifier than a detergent, because the emulsifier is what strips the fats out. But instead of doing that wash at 80 degrees, we'll do that wash at 55 degrees. Okay? So we actually will reduce the linen, but obviously like you say, the ozone at 55 degrees is not doing anything. So what you do, you do the wash.
It's not even there.
No. So you do your wash as normal to get the fats and greases out, and then you use the benefits of the ozone in the rinses. So when you rinse, it's like having a bleach wash in effect. So you're rinsing out the chemicals and it's helping you whiten your linen. Does that explain?
Is there any detriment to the linen? Because you mentioned you turned it into a bleach. The ozone is now.
No, because it's like a weak peroxide bleach. It has no detriment. It actually, because the ozone opens the fibres up, it's actually better for your linen. As I say, it helps you dry. Helps them. You know, if your towel fibres, if you think of those as your fibres on your towel, over time they shrink and get hard, and that's because you've not washed the excess chemicals out. So if you can wash the excess chemicals out, or the ozone breaks those chemicals down because you're not using so much chemical, then fibres then, when you've got the falling action, the dryer increases the efficiency of your dryer and makes it dry quicker.
So it's good for corporate linen. You mentioned that hotel linen. So it works its best.
It works its everything. So we've done trials at Johnson Group for the workwear side of things, and we reduced their chemicals by 30% and their energy.
So does it work on colours?
Yes, it works on colours. It has no effect.
Without any detriment?
No, it has no effect. Same as a peroxide bleach.
And what about engineering oil?
So with engineering oil, what you do, you'd use the chemical to release that oil. Ozone will not take that oil out.
So
yeah, we are. And that's,
sorry to all the questions, but
yeah, we are reliant on the likes of Christane's or Ecolab's chemicals to strip them oils out first.
So it relies on better sorting, classifying than perhaps many laundries.
Possibly, yes.
Yeah.
I mean, most laundries, we go and help them with their systems, it doesn't affect the system. Ultimately, if you can sort your linen quicker and better, yeah, the more efficient your laundry house will be. Because what people tend to forget is, if you're putting bath towels in with hand towels and flannels, the other two are drying so much more quicker than your bath towels, because they're wet and the rest are over dried. So by putting the washing in categories, you're actually reducing your time and getting better results and better fill for your customer.
How do you charge for your system, and can people produce it themselves and cut you out?
There's a few people in this room who'd like to cut me out, so no is the answer to that one. So what our system is, so basically what we do, we come to you, we'll view how many washing machines and what you've got, and we'll actually say, what size machine do you need? We don't just sell one size machine. Although the boxes all look the same, like a car, the engine insides are different. So we'll work out from yourself. So we've got customers that will sell to, say, for 14,000 up to 30,000. 30,000 machine will do lots of washing machines. You're not limited to that. So a 30,000 machine will be about $650 a month for you to buy. We come and install it, set up your systems, we reprogram your washing machines, we help you with your dosing systems and get that correct. And then after that, if you want us to come back, then obviously after the first 12 months, it's all inclusive. After that, when we come back, we do as much or as little as you want us to do. But our plan is to make you as efficient as possible and give you control back of your laundry. I mean, ultimately, that's the thing that we think is a big issue. You've got control. You tell us what you want us to do, and we'll advise you in the best way.
Forgive me for saying so, but you're providing the ozone. You've got to use other chemicals.
Yes.
You're trying to do the chemical companies out of business.
I'm not trying to do them out of business.
And other things. So perhaps you're having a little bit of a war with the chemical suppliers, because you have to find chemical suppliers that should meet entirely with your system.
Yeah. To be fair, we don't really have any arguments with the chemical guys. We've got a... I'm not there to get rid of the chemical guys. I have no intention of fighting them. I've got no intention of stopping their business.
Yeah, but Kate's only saying-
I do reduce their chemicals, but that's only a matter of the process. It's because if I put too much chemicals in, you're going to get the gall in if you're not got enough water. So there's other issues behind that, why I don't use other chemicals. But ultimately, I'm not against the chemical guys. They've got their own systems and stuff. But yeah.
On tabling specifically, a lot of tabling is 100% polyester.
Yes.
So a lot of the benefits you describe, I can see clearly with cotton, surely they're negated quite a bit.
Yeah, so polyester is still a cotton based on top, so you've still got the same cleaning.
But you're not going to get those benefits on polyester, are you? You've already got them anymore.
Not as much, no. You'll get some quicker drying times. It won't be nowhere near as yet.
And what about flame retardant fabrics?
It won't basically,
No detriment.
it won't have no detriment to that. All we'd have to do is obviously we'd work with the chemical guys or what chemicals they need. We'd go off their advice and what they thought for that, for something chemical retardant. I mean, the fire surface actually request ozone washing. Obviously, it gets rid of the bacteria, it gets rid of the smell of fire. So there's actually big contracts out there to be won.
They've got wool jackets, haven't they?
Yes.
So it works on wool as well?
Yes, it works on everything, yeah. There's a lot of big contracts coming up and they're all going to be ozone for that reason. Any more?
Any more questions? Sorry to have asked so many questions.
No, I'd rather people ask the
You
question.
find I'm a technical nerd. Things fascinate me. Thanks very much.
Okay, no problem.